I was sent this problem by Adonis, which was someone's screen name. There was a few things missing in the question, so I'm just going to go over them now. Okay, so I've added this smooth, inextensible, smooth again, and light. Okay, so those words were missing in the question you sent me. Smooth indicates that there's no friction on your inclined plane. So mu is going to be 1. Light says that the string in our mathematical model has no mass. Inextensible means that it's not elastic, and the pulley needs to be smooth. So that means there needs to be no friction in the pulley. Okay, so you're assuming that you get an acceleration when released from rest. So this looks like either a physics question or a mechanics question. Okay, so the question says a mass m2 kg is suspended from a smooth pulley by a light inextensible string connected to a second mass m1 kg resting on a smooth inclined plane at an angle theta. Show that the ensuing acceleration is g m2 minus m1 sine theta over m1 plus m2. Okay, so I've had a go at this. So let's look at the solution. Okay. So let's do this in, choose a colour, green. Let's do this in green. Okay, so I'm going to do this up here. Okay, so we've got our mass here, and this is m1 kilograms connected to our pulley. Got this m2 kilograms. We've got a theta, and we've got our reaction up there. We've got the weight acting down. Okay, so there's a few things we need to look at. So the tension, because it's connected, the tension is going to be the same throughout the string. And if we incline a plane at an angle theta, the resulting angle down is going to be theta also, and I've done that on the diagram. Okay, so the weight acting down the plane is going to be m1 sine theta, and that's just using simple trigonometry. m1 sine theta. Okay, so this is the resultant weight acting down the plane, m1 sine theta. And there's no vertical movement. The particle is at rest vertically. So that is m1 cos theta. And we've got a weight acting down, m2g, and g is the acceleration due to gravity. Okay, now let's resolve perpendicular to the plane. I'm going to do my resolving in yellow. So we resolve perpendicular to the plane. This symbol means perpendicular. Okay, so we've got R is equal to M1 G cos theta. Okay, there needs to be a G in here. Okay, so that is perpendicular to the plane. There's no movement, so we're not going to use that very much. Okay, so let's look at these two masses independently. So we've got a tension pulling the particle up the plane minus m1g sine theta acting down the plane, and that is equal to so here we're applying Newton's second law, F equals ma. F is equal to ma. And if you're asking me, well, where does this come from? This is the resultant. This is the resultant force. So this is equation 1. We've got equation 2, which is m2g minus the tension, which is m2a, applying Newton's second law. Let's call this equation 2. And it's a fair question to ask. Well, why is tension positive here in equation 1 and tension is negative in equation 2? Well, look, the acceleration is in this direction. So we're assuming that m2g is greater than the tension. If it wasn't, we wouldn't have any acceleration. So we've got two formulas. Got two equations rather. Okay, so we got equation 1, which is tension minus m1 g sine theta is equal to m1a. That's equation 1. We got equation 2, which is m2g minus tension is equal to m2a. Okay, so let's add equation 1 and 2. And the tensions cancel out, so we've got m2g minus m1 sine theta, and then we're left with m1a plus m2a. You should be able to factorize this now and rearrange to get part of what you're asked to find. So let's do this up here. Okay, so let's begin the factorization. There's a G missing there. Okay, so let's factorize the left-hand side. So we've got G m2 minus m1 sine theta. Okay, so that's beginning to look like what we're asked to find. And here we've got A m1 plus m2. Okay, let's divide both sides by m1 plus m2. Then we're left with G m2 m2 minus m1 sine theta all over m1 plus m2. And that is what we're asked to find. Okay, so I hope this helps. And the second part of your question was just subbing in the masses and the angle to find the acceleration, and we take the acceleration due to gravity as 9.8. Okay, hope this helps.